As DeFi continues to grow, making the most of your crypto assets and increasing decentralization is more important than ever. Imagine if your staked crypto could do double-duty work in multiple places at once, ensuring security and generating additional returns. With restaking, this is becoming a reality. That is what the restaking narrative is all about. Welcome to Oqtacore channel, and in today's video, we will dive into restaking, which allows your staked tokens to secure multiple protocols simultaneously, increasing your returns and contributing to a more connected and decentralized DeFi ecosystem. Whether you're a seasoned investor or new to the crypto world, stick around to find out how restaking is reshaping decentralized finance. And if you're excited, don't forget to give this video a thumbs up and subscribe to the channel. Restaking is a new narrative in the crypto world that allows the reuse of staked assets to create a shared security economy. Usually, when you stake your tokens, they help secure one blockchain network, and you earn rewards from that network. But with restaking, you can use the same staked tokens to secure multiple blockchain protocols at the same time. For you, this leads to better use of your assets and the potential to earn more rewards compared to traditional staking methods. Imagine you have a piece of land. You could just plant a lawn and enjoy life. Or, instead of a lawn, you could make the most of the land by planting a lush garden and installing solar panels and a wind turbine to generate electricity for your home and electric car. That way you make the best use of the resource that is land. Think of it like putting your money to work so hard it might just ask for a vacation. While restaking is innovative in crypto, the basic idea comes from traditional finance. In the past, similar concepts were used in financial products like synthetic collateralized debt obligations, or CDOs. Unfortunately, misuse of CDOs contributed to the 2008 financial crisis. However, the key difference is that in the crypto space, restaking is designed to be more transparent and secure. By learning from past financial ideas and improving them, restaking aims to build a more connected and efficient DeFi ecosystem that benefits everyone involved. Restaking didn't just appear out of nowhere. It was created to solve specific problems in decentralized finance. Two main issues push developers to come up with restaking are, first, low capital efficiency, especially noticeable with Ethereum's liquid staking derivatives. This means that the way assets were used wasn't as effective as it could be. Second, high complexity and costs in building security projects, particularly for projects that didn't fit neatly with Ethereum's scaling methods. This made it hard and expensive to develop new blockchain projects. To understand restaking better, let's dive into these challenges. For a long time, early blockchains like Bitcoin used something called proof of work, or POW, to verify transactions. POW was often criticized because it used a lot of energy and wasn't very efficient. In September 2022, Ethereum made a big change by switching to proof of stake, or POS. In POS, people called validators stake lockup 32 ETH to help verify new blocks and transactions. If they do their job correctly, they are rewarded. But if they act dishonestly or make mistakes, they can lose some of their staked ETH, a penalty known as slashing. However, staking 32 ETH is a lot of money. At the current exchange rate, it's approximately 84k, which is too much for many individual investors. To solve this problem, platforms like Lido and Rocket Pool created staking pools. These pools allow many people to combine their smaller amounts of ETH to reach the required 32 ETH. When you stake your ETH in these pools, you receive something called a liquid staking derivative. This LSD represents your staked ETH at a 1-to-1 ratio. What's great about LSDs is that they're liquid, meaning you can still use them while your ETH is staked. For example, you can first use LSDs as collateral. You can borrow other assets by using your LSDs as security. Second, you can provide liquidity in decentralized exchanges. You can pair your LSDs with ETH in liquidity pools on platforms like Uniswap, earning fees from trades. And third, you can just sell them. Imagine you had a deposit at a bank and you could sell it at any given moment for the total deposit principal plus accumulated APR. While the system obviously improved the effective use of assets and capital efficiency, it also introduced new risks. The first is centralization concerns. By January 2023, Lido controlled 76% of the ETH liquid staking market. This means one platform had a lot of control, which goes against the decentralized nature of blockchain. The second is potential for censorship. With so much control, there is a risk that transactions could be censored at the protocol level. The third is locked assets. A large amount of ETH was locked up in staking contracts, which meant it wasn't being used elsewhere in the DeFi ecosystem. In 2021, Ethereum's development team decided to move away from a scaling method called sharding. Instead, they introduced a concept called vertical scaling, which divides the network's functions into different layers and modules. While this helped in some ways, it didn't solve all the problems. Some projects couldn't use Ethereum's shared security features because they weren't compatible with the Ethereum virtual machine, EVM. These projects are known as actively validated services, AVS, and include 1. Keeper networks, systems that automate tasks on the blockchain. 2. New consensus networks, alternative methods of validating transactions. 3. Oracle networks, services that bring off-chain data onto the blockchain. 4. Cross-chain messaging protocols and bridges. They are ways to connect different blockchains. 5. Trusted execution environments, secure areas in devices where code can run safely. 6. Virtual machines, software that emulates computer systems. Each AVS requires its own unique way of validating transactions and reaching consensus, which added complexity and costs. Building separate security solutions for each project was expensive and not always effective. For example, in 2022, the wormhole cross-chain messaging protocol was hacked, resulting in a loss of $320 million. This complexity made it difficult to scale these diverse solutions efficiently. Restaking emerged as a way to provide a unified security mechanism. By allowing validators to secure multiple protocols at once, restaking helps different projects share resources and security, making the whole system more efficient. You could say restaking is the blockchain world's version of a carpool lane. Everyone gets to their destination faster and more efficiently when they share the ride. However, creating restaking wasn't easy due to the technical challenges involved in blockchain technology. This is where modular blockchains come into play. Understanding modular blockchains is key to grasping how restaking developed. Let's break down the 4 main functions that any blockchain needs to perform. Consensus layer. This is how all the nodes, computers in the network agree on the order of transactions. Execution layer. This involves processing and executing transactions correctly. Data availability, or DA layer, ensuring that transaction data is stored and accessible to everyone who needs it. Settlement layer, providing final confirmation of transactions and handling any disputes. In traditional or monolithic blockchains, all these functions happen within one system. While this can be secure, it often leads to problems with scalability, handling more transactions, and decentralization. This issue is known as the blockchain trilemma, which suggests that a blockchain can only have 2 out of the 3 qualities: decentralization, security, and scalability. To solve this problem, developers came up with the idea of modular blockchains. Instead of handling everything in one place, modular blockchains split these functions into separate layers or modules. Each module specializes in one function but can still interact with the others. This approach allows for specialization. Modules can optimize for their specific tasks. Flexibility. Developers can mix and match modules to suit their needs. And shared security. Validators can secure multiple layers or protocols, which is where restaking comes in. By separating the core functions, modular blockchains make it possible for validators to be economically incentivized to secure multiple protocols at the same time. This shared security is essentially the idea behind restaking. One of the first real-world examples of a modular blockchain is Celestia. Celestia separates consensus and data availability from execution. This means developers can create their own specialized blockchains called rollups that use Celestia's consensus and data availability layers. They don't need to set up their own validators because they can rely on Celestia's existing validator network. First of all, this approach reduces costs. Developers don't need to invest in their own security infrastructure. Second, this approach improves scalability. By offloading certain functions to Celestia, other chains can run more efficiently. And last but not least, this approach allows to reuse Celestia's native token TIA for security and resource allocation. However, Celestia isn't fully compatible with the Ethereum virtual machine and operates within the Cosmos ecosystem. This obviously limits its applicability for projects that are built on Ethereum. Around the same time, EigenLayer emerged with a similar idea but focused on the Ethereum ecosystem, and in fact it was the first restaking protocol. EigenLayer allows validators to restake their ETH or liquid staking derivatives to secure actively validated services, AVSs. By leveraging Ethereum's robust security framework, EigenLayer extends Ethereum's Ethereum's trust model to AVSs, enabling these networks to benefit from the Ethereum's validator set without having to bootstrap their own security. This dramatically increased the capital efficiency and security of projects building on Ethereum and beyond, effectively expanding the security guarantees provided by Ethereum's L1. Before we dive into how restaking works, let's firstly look at how EigenLayer is set up. EigenLayer has four main parts. Part 1. Stakers. These are users who stake, lock up their Ethereum or liquid staking tokens or LSTs like STETH or RETH. By staking, they earn rewards and help secure multiple services at once. Part 2. Operators. These are validators who keep the network secure. They validate transactions for actively validated services. Part 3. Actively validated services. These are projects that use restaking to benefit from Ethereum's network of validators, which adds security to their operations without them needing their own validators. Part 4. Main EigenLayer contract. Think of this as the central program that manages everything. It oversees how stakers delegate their assets, sets the rules for penalties called slashing, and controls how rewards are given out to both stakers and operators. Here's how restaking works with EigenLayer. Staking. Users stake their ETH or LSTs in the EigenLayer contract. This means their staked tokens now help secure not just Ethereum, but also the additional AVSs. Delegation. Stakers delegate their staked tokens to operators, validators. Operator registration. Validators sign up as operators. This allows them to take on extra tasks for the AVSs, extending security services beyond just Ethereum. Validation. Operators check and confirm transactions for the AVSs. Each AVS sets its own rules for how it should be done, including what happens if operators don't do their job correctly, slashing rules, and how decisions are made, quorum settings. This means each AVS can customize its security needs, slashing and veto. If operators fail to perform their duties, they can be penalized through a process called slashing, which means losing some of their staked tokens. EigenLayer also has a veto slashing committee or VSC that can overturn slashing decisions if necessary. Each AVS can create its own VSC, allowing for flexible and competitive ways to manage penalties. EigenLayer is still in its early stages. They're currently working on setting up the slashing mechanisms and expanding the shared security for AVSs. They plan to be fully operational by 2025. At the moment, EigenLayer has around 161,000 users who have restaked assets and 1,500 operators who validate around 25 AVSs. Recently, EigenLayer launched its own token called Eigen. This token helps with governance, making decisions about how the system is run, and encourages more people to participate. In addition, EigenLayer is adding cross-chain capabilities using tools like EigenCert and EigenBus. This means they can smoothly extend security across different blockchain layers and ecosystems, not just within Ethereum. EigenLayer has inspired developers to create a whole ecosystem of different restaking solutions. Let's take a look at some of the more interesting ones. Symbiotic is a restaking protocol built on Ethereum. It acts as a coordination layer that allows network builders to customize and manage their restaking setups in an open environment where anyone can participate, permissionless. It gives participants more control over important settings such as selecting node operators, assigning collateral, deciding how rewards are distributed, setting slashing policies. This means Symbiotic offers more flexibility than EigenLayer. Project uses ERC20 tokens and vaults to assign collateral to operators who manage infrastructure across various networks. Unlike EigenLayer, Symbiotic allows for more flexible and open operator selection. Additionally, in Symbiotic, resolvers are responsible for validating or vetoing slashing events, penalties, adding a decentralized governance component that is more customizable compared to EigenLayer's relatively centralized veto slashing committee. Symbiotic's design minimizes the need for trust in a central authority and is built to support a wide range of networks. This allows developers to adopt a modular and adaptable approach to restaking. In contrast, EigenLayer focuses on expanding Ethereum's validator set with more standardized configurations. So, Symbiotic offers a more customizable and decentralized alternative, enhancing the potential potential for innovation and tailored security across networks. Babylon is a restaking protocol that uses the security of Bitcoin's proof-of-work consensus to enhance the security of proof-of-stake chains through its own Babylon chain, built using the Cosmos SDK. We have a separate video about Cosmos SDK on our channel that we recommend you to watch. This integration allows proof-of-stake networks to leverage Bitcoin's strong and censorship-resistant blockchain without needing to create their own validator sets. It offers a hybrid model that combines the resilience of Bitcoin with the efficiency of proof-of-stake systems, including low energy use and faster transaction confirmations. By connecting proof-of-stake chains to Bitcoin's established security, Babylon provides a compelling way to scale and innovate without requiring each network to build its own security from scratch. Babylon allows Bitcoin stakers to bring their proof-of-work security to proof-of-stake networks, while EigenLayer enhances security within the Ethereum ecosystem by relying on Ethereum's validators. Babylon leverages Bitcoin's network and connects it to proof-of-stake chains in the Cosmos ecosystem, offering a solution that works across different types of blockchain systems. Carrack is a multi-purpose restaking protocol that enables restaking with multiple types of assets across Ethereum and other blockchain ecosystems. Its modular design allows stakers to allocate various assets like ETH and stablecoins into distributed security services, DSS. These DSS use the staked assets to enhance the security of decentralized services without relying on rewards that increase the total supply of tokens, inflationary rewards, providing a more efficient way to secure the network. Carrack's infrastructure doesn't depend on any single blockchain. It's chain agnostic, so it can be used across multiple blockchains, offering great versatility. Its architecture uses ERC-4626 tokenized vaults, managed by operators who allocate staked assets to DSS. It also supports custom vaults, where developers can create tailored economic models, including specific slashing rules for different types of assets. This flexibility allows Carrack to secure a wide range of applications and take advantage of the combined security of multiple networks. SolLayer is a restaking protocol built on Solana blockchain. It leverages Solana's high speed and low cost performance to secure both native Solana applications and external services, with a particular focus on Solana's own dApps. Validators can restake their assets to secure various decentralized services, optimizing Solana's proof of history and Tower BFT consensus mechanisms to achieve high performance and scalability. This makes SolLayer ideal for applications that need speed and low transaction costs, aligning well with Solana's strength. The project integrates seamlessly with Solana's system, allowing easy interaction between native dApps and the validation infrastructure. Validators restake their assets into validator-specific vaults, which are used to secure different decentralized services, both on Solana and across other chains. This setup provides strong security and scalability, enabling developers to fully utilize Solana's infrastructure for various purposes. Restaking is set to reshape the DeFi world, extending economic security beyond a wider range of projects. As early as 2025, restaking could become a standard feature, offering better incentives and multiple layers of security. Almost every market segment could potentially benefit from restaking. Tokenizing real-world assets, RWA. Restaking can secure digital versions of real-world assets by preventing double spending and tampering with ownership records on the blockchain. Decentralized social media. Restaked assets can improve content control and moderation on decentralized social platforms, reducing censorship and spam through penalty mechanisms. Decentralized content sharing. Restaking can secure content sharing platforms, encouraging honesty and reliable access while penalizing malicious actors. Crypto gambling platforms. Validators using restaking can ensure fair and secure management of bets and payouts, boosting user confidence in crypto gambling. Blockchain gaming platforms. Restaked assets can support blockchain games by securing transactions, ensuring fair trades, and protecting in-game assets, with penalties to prevent cheating. Cross-chain dApps. Restaking could provide a unified security layer for decentralized apps operating across multiple blockchains, making cross-chain transactions simpler and more secure. Blockchain analytics platforms. Restaked collateral can ensure the accuracy and reliability of on-chain data collection and processing, making blockchain's analytics tamper-proof. Open AI networks and agents. Restaking protocols can incentivize AI networks by ensuring data security, computational accuracy, and penalizing errors like AI making up facts. Privacy networks and public services. Restaked assets could provide the infrastructure and financial incentives for decentralized services like privacy networks, API providers, and public goods platforms. Restaking protocols are revolutionizing blockchain security by allowing validators to extend their influence beyond the original networks and enhancing asset efficiency. These protocols offer innovative ways to boost yield and security, creating new opportunities for decentralized services. As restaking grows, the focus will be on building resilience, ensuring that protocols develop robust frameworks to manage risk and optimize performance. While many see restaking as a promising investment and a significant advancement in crypto security, others remain cautious, viewing it as risky. Its stability is untested in extreme market conditions like a bear market. But hey, in the crypto world, if you're not occasionally wrestling a bear, are you even investing? Despite these concerns, we believe that this evolution will enable the restaking ecosystem to mature and become a core component of decentralized finance, fostering more inclusive and interconnected blockchain networks. Restaking holds immense potential for reshaping how assets are secured and utilized. We'll continue to monitor the latest news and insights in DeFi and AI. Don't forget to subscribe and like this video. See you soon.